Good afternoon. This is Professor David J. De Los Reyes, an electrical engineer and an electronic troubleshooter. My topic this afternoon will be a new topic. It is an interesting topic on the climax topics on integral calculus. It is the derivation of the formula for the circumference of an ellipse. The formula you are using under lower mathematics, in which the circumference of an ellipse, which is actually pi times the quantity a plus b, actually was derived from integral calculus. Okay, let's try to derive the circumference. Okay, let's proceed. I am now on lesson number 89 on my channel under the topic integral calculus, subtopic length of arcs. And for this afternoon, I will derive the circumference of an ellipse as a function of the major axis and minor axis. Actually, circumference for an ellipse, it's not actually a circle, but it was a special case of a circle. So I will just say circumference or perimeter. It will be the same, meaning the total distance moving around the ellipse. It will be pi times the quantity a plus b. So the formula you are using under lower mathematics, in which the circumference or perimeter around an ellipse is actually pi times the sum of the quantity major axis plus minor axis units. Okay, so this afternoon we will derive this formula using integral calculus. At least you know, guys, where your formulas are coming from. You don't just use your formulas without knowing where it originates. Okay, I will try to read the problem. Derive by integration the circumference of an ellipse with major axis small letter a and minor axis small letter b. Let's try to bring out the figure on the Cartesian coordinate system. Don't worry, we are just on the xy plane. We are not involved for the so-called volume. We are not on the xyz plane. We are only on the xy plane, so don't worry. This will be the y-axis, x-axis, and this will be the ellipse. This is the major axis. This is the minor axis. This point here is with coordinates a0. The abscissa here is a, the length of the major axis, and the ordinate is 0. For this point here, the abscissa will be 0, and the ordinate will be this. Sorry for this one. This should be small letter b, guys. Syntax error. Okay, abscissa is 0, ordinate will be small letter b, it is the minor axis b. And the equation of the ellipse, since the center of the ellipse is at 0, 0, the equation will be x squared over a squared plus y squared over b squared equal to 1. The differential arc is this triangle here. And if you try to bring it out, it will be something like this. This is dx, this is dy, and this is ds. Right angle. ds. This is ds. Okay. Let's try to bring out the solution of this one. Number one part of the solution is try to bring out the differential length of arc under case number 1. This will be differential length of arc equal to the square root of 1 dy dx quantity square all multiplied by dx, equation number 1. Okay. I would like to use the differential situation, okay, because this is dx. So it is a must that I will compute for y as a function of x, right? If this is dx, the terms inside the radical should be y as a function of x. it will be a pure x, no y, so you can integrate. To bring out the relation of y as a function of x, take the equation of the ellipse, right? X squared over a squared plus y squared over b squared equal to 1. That's analytic geometry, right? Okay, that is the equation of an ellipse with center at 0, 0. The major axis is A and the minor axis is B. And the major axis coincides with the x-axis. The longer one, which is termed major axis, coincides with the x-axis. Okay, to simplify solution, for the meantime, we assume for the meantime that the major axis is equal to the minor axis. For the meantime, okay? That is only to simplify calculation. So if we assume for the meantime that the major axis is equal to the minor axis, we'll go back here. X squared over a squared plus y squared over, if a is equal to b, this should become a squared, and this should be equal to 1. Multiplying all terms by a squared, then transposing terms, y squared now will be a squared minus x squared. We transpose that to the right. Then taking the square root of both sides, right? To solve for y. These two here cancel with this. Left hand side will be y equal to the right hand side, the square root of a squared minus x squared. Let's try to compute for dy dx. dy dx will be the derivative with respect to x of y is just dy dx equal to the derivative of the right hand side. Okay? Actually, the right hand side falls under the power formula. Okay? U to the n. Sorry for that one. U to the n. It should be n u raised to n minus 1 times du. Or you could use the derivative of a constant. Okay? Or just simply like that. Right? So after the simplification, what will come out for dy dx will just be simply minus x all over the square root of a squared minus x squared. Right? Let's try to square both sides. Dy dx quantity square will be dy over dx quantity square equal to the square of the right hand side. Negative x to the second power will be plus x square. The square of the square root of a square minus x square, the radical sign will vanish, so it will be a square minus x square. Okay, equation number 2. It's just a matter of simplification, guys. Equation number 2, we get this value here, we put it here. Differential length of arc equal to the integral or the square root of 1 plus the square of dy dx, which is x square over a square minus square times dx. If you try to simplify this one, it's just a matter of algebra, guys. What will come out for the differential length of arc will be a dx over the square root of a square minus x square. This is x square. And for the meantime, this does not fall under the power formula. Because if you try to differentiate the terms inside, there should have be a negative 2x dx over here. There is no x on the numerator, so it does not fall under the power formula. So whether we like it or not, we will use integration using trigonometric substitution TS. We let x squared equal to a squared sine square of theta. Take the square root of both sides. X now will be a sine of theta. Perfect square, perfect square, perfect square. Take the square root, it will just be simply linear functions. X, a sine of theta. Compute for dx. Dx will be a cosine of theta differential theta. We'll try to solve the value of the square root of a square minus x square. Square root, separately, for us to be systematic. It will be the square root of a square minus a square sine square of theta equal to a square. We factor out. 1 minus sine square will be cosine square. Take the square root. Perfect square, perfect square. The equivalent of this will just be simply a. the major axis times cosine of theta. We try to integrate this one separately. We bring out this one. We put this one over here. So it seems we are integrating only just this. Separately, okay? Before we will substitute the values. The integral of dx over the square root will be the integral. Dx is actually a cosine of theta differential theta. Okay? All over the square root. The square root is actually a cosine of theta, a cosine of theta. Luckily, a cosine of theta cancels. Right? So what will remain on the right hand side will be the integral of the differential theta. The integral of the differential of theta will be theta. Okay, let's try to express theta in terms of x. So from sine of theta, which is actually x over a, sine of theta is x over a, theta will be x, arc sine of x over a. So if we will now try to go back here, okay, the integral of the differential length of arc is just s equal to, we got an a over here, this is a, okay. Our limit will be from 0 to a, okay. X should move from 0 to a, okay, to cover this distance, then times 4. That's why there's a times 4 over here. Okay? So this should be 4a, arc sine of upper limit, arc sine of x over a, arc sine of 0. This should be a over a, guys. I substituted the value of the upper limit over a. Upper limit will be arc sine of a over a. Lower limit will be arc sine of 0 over a is just 0. This is actually 0 over a. Okay. Arc sine of 0. 0 over a is 0. Arc sine of 0 will be 0. So this is 0. And the value of this is pi over 2. So the resulting equation will have simplification will be 4a times pi over 2, and which the resulting value will be 2 pi a. That is the circumference of an ellipse as a function of the major axis if a is equal to b. So assuming a is not equal to b, what will come out? Because we could rewrite this one as pi. Okay, 2a is actually a plus a, right? But if a is equal to, not equal to b, the second part will be b, right? Okay, right, you got it? So if we try to simplify, perimeter or circumference or an ellipse now will be pi times the quantity a plus b. Because for the meantime, a is not equal to b. But just in case a is equal to b, it will just be simply 2 pi a. But if a is not equal to b, this will become pi times the quantity a plus b. Or as a general formula for the circumference of an ellipse, it will be pi times the quantity a plus b. Major axis, minor axis, units. So it is this. So for my colleagues who are teaching lower mathematics, the formula you are using for taking the circumference or perimeter of an ellipse, in which that formula is circumference is equal to pi times the product of a plus b. Okay, guys? That's the formula for taking the circumference of an ellipse. We are gone in this world, but this formula will not change. So circumference will be pi times the quantity, the product of sum of a plus b units. Good afternoon, Los Angeles.